Hey everyone, Danielle here from Mastering Mathematics, and today's video we're exploring matrix algebra, but today we're talking about scalar multiplication of matrices. Let's hop right into it. First of all, we need to talk about scalars. What are scalars? Can you recall what a scalar is? A scalar refers to any numerical constant, something that's just magnitude. So when we talk about our numbers, our real numbers, our integers, our whole numbers, rationals too, we're talking about scalars. Do you recall the square matrix called the scalar matrix? That particular matrix, all the elements on its leading diagonal were scalar multiples. This means that all the elements were multiplied by a particular number. Now, when we talk about scalar multiplication of matrices, it means that we're multiplying every element in our matrix by a particular scalar. So if you look at this illustration, you'll notice that when we want to find 3 times this matrix, we're multiplying every element in this matrix by 3. And that's how we're going to get the scalar multiple of this matrix. Now, we can use scalar multiplication in conjunction with other operations. So take a look at this particular question. Can you do this one? If you recall how to do matrix subtraction from our last video, you'll be able to do this particular question. Now, I've outlined it step by step, so you can do it on your own, and then you can come take a look at the solutions and see if you're doing this properly. Now, here we want to start off by evaluating the scalar multiplication for 3 times our matrix D. Taking a look at the matrix D, what type of matrix is that? You could remember? Now, once we have our multiplication down, now it's just to subtract, finding the difference. Once you remember how to do that operation, we'll be able to get a result. So check to see, did you get this final matrix as your answer? I hope you had no trouble whatsoever with that question. And remember to stay tuned. We still have matrix multiplication to do and lots more to explore in the matrix.